For today's lesson, we will discuss about Descartes' rule of sign on how to determine the possible number of zeros in the polynomial function. So I have here one example. Determine the possible numbers of positive real zeros, negative real zeros, and imaginary zeros for f of x equals x raised to 6 minus 2x raised to 5 plus 3x raised to 4 minus 10x cubed minus 6x squared minus 8x minus 8. So first thing to do is we are going to check the positive real zeros by using this f of x. So we are going to substitute the positive x to the x here in the given polynomials. So we have x raised to 6. The second term we have negative 2x squared. So if we are going to substitute the positive x, so it's still the same. We have x raised to the 6th power, then minus 2 times x raised to the 5th, and then plus 3 times x raised to 4, then minus 10x raised to 3, then minus 6x raised to the 2nd power, then minus 8 times x raised to 1, then minus 8. So as you will see, even we substitute the value of x here in the given polynomials is still the same. Now we will identify the signs of each term. So x raised to 6 will become positive here. Same here, we have a negative sign, we have a positive sign. Then of course x raised to the third is x raised to third times negative 10 equals negative also. So we have a negative. Then same here, we have a negative also, negative sign. Then negative also here. Now, the important here, if you will use the Descartes rule of sign, is we are going to identify the variations. To identify the variations, just look at the alternating in signs. So alternate in signs. So we have positive, negative, so counted as one variation. We have also negative, positive, so we have now 2 variations. Then positive, negative, so we have 3 variations. Okay, so and here no more. So total variations here will be we have 3 positive variations. So just write here the number of variations, positive variations. So we have 3. Where did we get the 3? From here. So 1, 2, and 3. And the second solution here, using the Descartes rule of sign to determine the possible numbers of positive real zeros, negative real zeros, and imaginary zeros, is you are going to substitute f of negative x to the given polynomial function. Okay? Now, if we will substitute it, it will become now negative x raised to 6 minus 2 times negative x raised to the 5th plus 3 times negative x raised to 4 minus 10 times negative x raised to 3, and then minus 6 times negative x squared minus 8 times negative x, then minus 8. After that, we will simplify this. So if it is even, then raise to an even number, so the answer will be positive. So positive x raised to the 6th power. Then since the exponent is an odd, so it will become negative. Then multiply to negative 2, so it will become positive 2x raised to the 5th power. So this is even number, so negative x raised to the 4th power, so the answer is positive. So just copy the sign, so plus 3x raised to the 4th power. Then the exponent is an odd number, so we have negative x raised to 3, so negative times negative will become positive 10x raised to the third power. So the exponent is even, so negative the base, so it will become positive times negative equals negative x raised to the second power. Negative times negative equals positive 8x. By the way, so we have here 6, then minus 8. Okay, then we have now the sign. We have positive here, positive, 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 negative, positive, and negative. So let's count the variation. So we have 1, 2, 3. So therefore we have 3 negative variations. Okay, now since we have 3 positive variations, we have 3 negative variations, so we will look for the imaginary zeros. Number of possible imaginary zeros is how many? So let's make a table here. So we will divide it into 4 columns. So the first column is your positive zeros. Second is your negative zeros. Then the third column will be your imaginary zeros. And then here is your total number of zeros. Okay, so that is your table now. So for the positive zeros, just write 3. So we just copy this one. And then for the negative zeros, we have 3 also. Then the total, we will base it from the highest degree, which is 6. So just write here 6. So 3 plus 3 equals 6. Then 6 minus 6 is equals to 0. So we have now 0 here. Imaginary zeros in the row number 1 is equals to 0. So this is the first possible number. So 3 positive, 3 negative, 0 imaginary. Okay. Then another option will be, we will subtract this by 2. So 3 minus 2 equals 1. Same with this, 1. And then here is still 6. So it's equals to 6. And then to find the imaginary zeros, just add 1 plus 1 is 2. Then 6 minus 2 is equals to 4. So therefore, we have now 1 positive 0, 1 negative 0, and then 4 imaginary zeros. So this will be the possible numbers of positive real zeros, negative real zeros, and imaginary zeros of the given polynomials here. So I hope everything is okay. So I'm hoping that you understand these solutions. Okay, so thank you for listening.